Welcome back. I'm Buddy Lindsay. I'm the host of the Go Rust channel where we're going to try to learn how to do Rust. And in this case, we're doing it in the context of learning Solana development. The last couple of weeks, we started out by trying to figure out, hey, what is the, how do we get up and running with it? And then last week, we were like, hey, let's write something to the chain, our local test chain. And this week, I want to see, like, there's the concept of multiple accounts. I don't understand that. So I want to do a little research on that, and then maybe we can write some code to use that. But first, let's take a look at some of the stuff that we've already done and kind of go over it a little bit. So here we go. One thing I wanted to bring up is I did a little search and I found out that for some reason the Solana Explorer does not work with Brave. Or doesn't work right with Brave, I guess. So if you open it up in Firefox, it seems to work just fine. So this is the program address that we have. So this is the balance of Sol, executable. Let's see. This is the data. It's just information. I don't know what a lot of this information is right now, since I'm still so fairly new to everything. But like, this is stuff and things, and it's pointing to the 8899 of the local JSON RPC endpoint. So cool. We have made progress. We have learned something. So let's go back. So let's look at some of our code. So we wanted to look at writing to the chain. In this case, we're in the client area first, so let's look at that code. So we started out with the get Solana client. This just gets the RPC client for us to actually use. This is getting our key pair that's for our local system and returning back a key pair object. So that's just set pat stuff. Then we want to get the program ID that we want to execute. We want to generate a new key pair for an account. Then we want to say that we want to allocate 1 byte of space for that account. Then this is something that I need to like look up, but I'm pretty sure what this means is, logicking it out, is that we can create an account that will go away unless we put a minimum balance so that it doesn't go away. That's kind of how I'm reading this. So let's assume that's what it is for the moment. So I'm assuming this is just get what that balance is based on the amount of data. That's interesting. So if I were to do like, let's see, 1024, then I guess you're renting space on chain, and you do this to figure out, hey, what is the minimum that I need to put in there to make sure it never goes away. Makes sense. Okay. Anyway, so then we're going to do a system instruction to create a new account. We're going to say, hey, this is the person that's going to pay for the account. The pub key is that key pair we generated up there. This is the amount I guess we're going to throw to it. How much data we're going to use. The account size and program ID. I guess that program ID down there is the owner. Okay, the owner. Okay, so if we look at this, pub key from pub key to. Okay, I guess we're sending money from this key to this key, which is the new account. Landport's the amount that we're sending. Space, the amount of space that we want to reserve. And then the owner of this account, okay, is going to be the program. Okay, cool. So that says, I guess, that the program can access and deal with that account. Allocate space, transfer land ports, and assign to its owning program. The create account function does all three at once. Okay, cool. I think we kind of, well, let's look, see. These examples use a single invocation of create account to create a new account, allocate some space, transfer in the minimum land points for rent exemption, and assign it to the system program. Client-side RPC, this is the example. Oh, okay, that's just using it. Example on chain program. So I guess this is example submits instructions from an on-chain Solana program to create account. Okay. Anyway, don't worry about that. Okay, so then we're going to create a new instruction. We're going to push a number onto this. Then we're going to... Okay, the instructions are going to be a vec of data. So then we're going to create a new instruction object. I don't understand this new with Ben code. So say create a new instruction from a value encoded with Ben code. I don't... Is that binary code? Can I click on this? Ooh. Ooh. Ooh, that's cool. Alright, the bin code is a crate for encoding and decoding using a tiny binary serialization strategy. Okay, nice. Using it can easily go from having an object in memory, quickly serialize it to bytes, and then deserialize it back just as fast. Bin code. So I'm assuming it's going to and then we would need to maybe, I don't know. So that's not actually what I want to do. Okay. New with bin code. Create a new instruction encoded with bin code. Okay. And this is using serialize, deserialize. Still, I gotta learn on that one. Okay. Okay, but we're gonna say the program ID that's gonna execute it. Program ID, data, so the vec, a reference to that data, then the accounts that are going to be involved in it, right? Though I don't account meta new. Okay, I don't know what account meta is. Describe a single account read or written by a program during instruction execute. Describes a single account read or written by a program. When constructing an instruction, a list of all accounts that may be read or written during execution of that instruction must be supplied. Any account that may be... Okay, my brain is not processing. But let's see. Pub key is the new account we're creating in this case. And then is signer false. So looks like there's a third one. Is writable. I guess that's probably false by default. Okay. Anyway, let's move on. So message, I'm assuming, is the message we're going to send to the chain. Solana transaction message. Yeah. So that's just, yeah. So now we're saying execute all of these instructions. So in the case, the account creation instruction and this instruction. Pay for it with our local account. We got it. Then we are getting the latest block hash. Then we're creating a new unsigned transaction. Then we're signing it and connecting it to the block hash that we're going to sign it with. and then we're referencing the payer and the account. I'm assuming because they're going to be interacting with this method is fully signed the transaction with all required signers, which must be present in the key pair slice. To sign with only some of the required signers, use partial sign. Okay, that's a concept I don't understand yet. Then we get the signature send and confirm transaction to send that transaction up. And it's just going to pull and wait, like we had a little bit of a discussion last week. Cool. I think this is fairly straightforward. I think we kind of got it. All right. So let's look at the library here. So we're going to get the program ID. We're going to get the accounts. And that's going to be an iterator. And so we'll iterate this. It's going to get the iterator. And then this is just going to step one at a time. If we had multiple accounts, we do let account 2 equals next account info, on and on and on. To unpack. I'm assuming they're going to go in a specific order so you can unpack them out of order. Then we're going to get the instruction data. I wonder if we can do a curiosity bin code. Use bin code. Yeah, I don't know. I'm not going to worry about it right now. It's going to get the data out of it. It's going to print it. They're going to write it to the log, to the Solana log. Then we're going to get our account data. We're going to get a mutable reference to the account. And then we're going to write to it. That's what it's going to do. I have a general understanding of what everything is doing, but there's a lot to still learn. It's still to take on. So, cool. All right. Let's come to Jippity. Solana seems to have a... I'm going to play with something here. You know what? Let's try to, muddle. Let's muddle. See what we do. I want to muddle. All right. I want to do this. So we have our... Let's not worry about that. We have, let's see, data account. I don't know. I eventually want to make a lottery system on here. So let's just use some of that naming. Let's do numbers account for the sake of... Let's do let addresses, let participants account equal key pair new. Okay. And so we're going to get a new key pair there. Let's say for... Let's build these out. Let numbers account size equals, just do 1024. Space is free when it's local. We're going to do let participant account size equals 1024. Okay. So then we want to do let rent exemption amount for numbers account equals client dot. We're gonna do it. We're gonna do it. Get minimum balance for rent exemption, numbers, account size, right? Let RIA participants account equals client dot get rent. Get. There we go. We do participant account size. Cool. These technically should be the same amount, but we're going to be a little bit explicit at the moment. Okay, let's knock these out here. So then let's do let create account instruction. Create account instruction, numbers, account equals, system, instruction, create account. This is going to be the payer pub key. The numbers account pub key. The RIA amount. The numbers account size as U64. Okay, I guess we still need this. And a program ID. So there we go. Okay. My value account, this scope. Let's not worry about it right now. Let's just keep typing. Let chi numbers equals system instruction create account from pub key is participants account to no okay from is at payer dot key dot pub key, and then we want to do at participant account dot pub key. Then we want to do RIA participant account size, and I think it's at program ID. Okay. All right. So I don't actually care. We're gonna kill this completely. I don't care. What I want is CAI numbers account CAI or to oh participants account because I want to make sure that I'm using a CAI participants account. Okay. Cool. We're going to get it, and now we want to make sure that we are using the numbers account and the percent chi. No, participant account. Cool. We got it. So the question, cool, I think so. The only thing we're doing is system transactions to create accounts. So this is like if we were initializing what we were doing. So cargo build. So really what we care about is creating the accounts. I want to create these accounts, and then the next thing that I want to do is try to get the account numbers, like whatever. I don't know. I don't know what I'm actually after for sure. And then I want to see if I can load those and then write data to them and then access them again. Because right now we're just creating a new account every time we run this. I don't necessarily want to keep doing that. Cargo run. Transaction successful. Okay. Let's look over here. Program transaction executed. Status message. Invoke. There's one invoke, a success, and invoke and a success. I'm assuming that was me. So ZQ8, Q, ZQ, yeah. So there were two invocations and they were successful. So I'm looking at this one. So based on this one, looking at the log up here for this last one, there's one execution invoked. It was successful. The program, which is jam, yeah. And then this is the log of everything that was in there. And then the next. And then jam was a success. Oh! Scratch that. I was actually right. But here, okay, this is good. This is good information on how to read the logs. So this was the system program execution. Just like here. It was successful. It invoked. Now we're invoking this program, our jam program, logging out the data, which shouldn't be one, and then we're saying, hey, the program consumed this much of this much compute unit, and then we were a success. that makes sense on how it works. So we did have 2 program executions in there. One was just system level. Nice. Okay. So now that we know that, let's jump over to Firefox. Okay. So confirmation status is finalized. Okay. Okay. I don't know how to read this stuff. Upgrade. Okay. I don't know what's going on. What? I apparently don't understand something. Okay, I don't know. I don't know why. I don't know what's going on. That doesn't make sense. Okay. So let's look at. So we sent off the thing. Whoop. And we get a client result back. Let's go there. All right. Submit a transaction, wait for confirmation after send blah 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 blah. Yeah, this isn't giving me what I want. Cute. Escape. Stop. Something. I don't know. Uh, when we are dealing with multiple accounts for a program, how do I reference those accounts in the future? See, when dealing with multiple accounts in the Solana program, it's important to understand how to reference and manage these accounts effectively, both within the program and from the client side. Agreed. The accounts are identified by their public keys. Agreed. And the order in which they are passed to the program is crucial. I was right based on some of the code. Here's how you can work with multiple accounts and reference them in future transactions. Okay. Account order index. Accounts are passed to the Solana program in a specific order. Thank you. Inside the program, you reference each account. Blah, 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 blah. The program, blah, blah. Program is the account info struct, right? Yeah. To access account data. Okay. Yeah, I agree. Okay. Handling multiple accounts from the client side. From the client side, when you create an instruction, you must pass the accounts in the correct order as expected by the program. Right. So this is okay. Count back. Okay, just new with bin code. So yeah, we're passing in stuff, and then instruction data is nothing at this point. Okay. To reference these accounts in the future transactions, you need to keep track of public keys. Each account is identified by its public key. You'll reference these public keys in future transactions to interact with the same accounts. Recreate the account meta. When creating new instructions, you'll use the same public keys. That makes sense. That makes so much sense. I feel stupid for not thinking about that. Yeah. Always pass the accounts of the So we need to output. We need to print what the pub key is. Account order. Accounts are accessed by their order. Yeah, we know that. Indexing, reference feature. Maintain consistent. Be careful managing order and reference. Blah, blah, blah. Okay. So let us change some things. Can we do a message? Can we do... numbers account dot this is returning a new ran as OS are okay. Right. Let's do this. Print line. I think it's numbers account. Let's see what this does. Yeah, key pair right there, yeah. So that leads to the question. So in all the examples, we just spin up new key pairs with key pair new, which is great for testing purposes, but for actual development, for actual long-term use, usage is not a great idea. But it's a good way to get and store key pairs for future usage for these accounts, or am I missing something? See how it goes. I am absolutely right. Thank you, ChatGPT, for stroking my ego. All right, you're absolutely right. Using key pair to generate a new key pair on the fly is fine for testing, but not suitable for long-term or production use. You need persist accounts that can be referenced across multiple sessions or transactions for long-term usage. You need a way to generate, store, and retrieve key pairs securely. Below are some of the common practices for managing key pairs in a more durable way. Using a wallet. We'll note. The Solana CLI has built-in wallet functionality that can generate and manage key pairs. When you create a new key pair using the CLI, it saves the key pair as a JSON file. Load a key pair into your Rust code. Just like that. Storing key pairs in a secure location. Environment variables. For simple setups, you can store key pair path in an environment. Secret management systems. Yep. Using hardware wallets. Gonna skip that. Key pair recovery. Gonna skip that. Deriving a program addresses. Solana programs can create and use program-derived addresses (PDAs), which are deterministic and and don't require private keys. Okay, okay. Example. C, so program ID from string. Your program ID here. PDAs are useful for program-owned accounts where you want determinism and security without managing private keys. Okay. Feel like this is a thing to research and learn more about later. Storing key pairs and configuration files. You can store key pairs as JSON files and reference them in your Rust program. Right. Okay, yeah, I agree. So we need to generate 2 key pairs and save them for usage and load them up. All right. So let's do Solana. Let's go back here. Solana keygen I have it in Solana ID. Just okay. Solana. Okay. Okay. Key Solana keygen output file config Solana, and then I want to do participants.json, right? It lies. Out file. Oh. Oh. Exactly. Care them source name. Let participants equals that. Just for giggles. Okay, and let's do Solana keygen. Let's do numbers. Go. Let numbers equals that. There we go. What? Syntax error expected. Oh, const. Okay. Cool. Fine. I'm cool with that. At the moment. All right. Okay. Okay. Sorry. All right. So we have okay. So we ran the system once, created. We have not created the account yet. So what we want to do now is let numbers account be pub key from stir numbers, which is our const dot unwrap. No. No. Maybe. Maybe. Let's try it. Let's try it. What's the worst gonna happen? And not work. The method pub key. Oh. There we go. We have that. Now we want to do this one as participants. Cool. So in this case, I don't think it's going to work because actually I don't know. We're going to run it. We're not going to argue with it. I want to see it blow up. If it blows up. Numbers account. Mismatch type. Okay. So sign needs a key pair. That's what I was wondering about, but it wasn't clicking. I was wondering about the signing, if that was going to be an issue. Pair. Key pair. Okay. Not a problem. So what we're going to do is we're going to do function get numbers pair. Numbers function get participants key pair participants. Go. And then we're going to do get numbers. Then we'll want to do dot pub key again. Get participants. And we'll want to do dot pub key again here. Sweet. Cool. Let's do cargo build. Nice, nice. Cargo run. All right. Before we execute, what are we going to do? We are using the pub keys that we created, that we generated. We're going to create accounts for them with system instructions. And then later, and then next, we're going to want to create a contract that interacts with both of those. We'll see. Nice, nice, nice. Let's come here. Let's hurry to Firefox. Paste, go. There we go. Account inputs. Fee payer, signer, writable. Okay. System program. Okay. Instructions. Okay, cool. We have it. We have data. Signature, result was success. Timestamp. Confirmation status, finalized. Confirmation max comfort slot. Recent okay. Fee was that many. 300. Transaction version is legacy. Oh. Right. Address. Account inputs. So the fee payer is this address. Signer and writable. So these are the two accounts that we wanted to create. Let's double check. So 8YZ. So that's our participants account. And then FY, okay. And then the system program. Note the exact same amount of balance for the rent-free. Cool. Okay. So system program, create account. Okay. The program is a system from address here, which is the payer. New address. I don't understand that. Okay, but transferred that. Okay, allocated 1,024 bytes. Allocated 1,024 bytes. Program return success. Program return success. Okay. Well. Very cool. And we can go verify that in the logs. 2 executions. That transaction hash, which is that one right there. They were success. Cool. Okay. I know what to do. All right, let's give this a shot. So now what we want to do, we're no longer going to be creating. So let's do this. There we go. So now we're getting those accounts. So now what we want to do is let's send money, send to numbers equals system instruction send. Oh, transfer. Is there a transfer? Okay, transfer from payer dot pub key. To numbers account dot pub key. Okay, and how much do I want to do? LAN ports, let's do 10,000. 10, 1, 2, 3. Okay. Awesome. So let's come down here. We want to do the same, except we want to do 20,000. We want to go to participants account. Participants. Cool. So now we want to do send to numbers. Send to participants. Okay. We're dealing with the pair, the numbers, and the participant account still. Let's go to those key pairs. All right, so this should send LAN ports to those two accounts. Cargo build. Cargo run. Yeah, key pair pub key mismatch. Transaction shine failed. Let's see. Okay. Numbers account, get number, yeah. System instruction transfer. We're doing payer pub key, numbers account, dot pub key. Participants account. Just out of care, I mean, just to make sure here. Participants. Okay. Send. Okay, so we're signing. Whoops. Fully signs transaction with all required signers, which must be present in key pairs slice. Sign with only some of them. Okay. Recent block hash is different than recorded. Blah blah. Program ID payer. New transaction new with payer instruction. The instruction is new with Borscht for the Borscht serialization. Okay. But, I mean, if I remember right, like, it's like, it's gonna pull in a reference to the key pair, so it should just be okay. That makes sense. Okay. What was the error again? Error transaction sign failed with error key pair pub key mismatch. Okay, let's double check our pub keys. Okay. Payer pub key, numbers account pub key. Okay. Payer pub key, participants account pub key. Okay. We want these two instructions. Payer pub key. Okay. Okay. Let's just see what just the raw message here tells us. Because the public key derived from a key pair does not match the expected public key for a transaction. This typically happens if the wrong key pair is used to sign a transaction or if there's a mismatch. You know what? I wonder if, because I'm transferring, I don't need these two. Because I'm not doing anything with those accounts. I'm just sending. I'm just saying, yo, here's some money. There we go. That was it. That was a good learning experience right there. I like it. Cool. Cool. Finalized. Confirmations max. Okay, so this is the one. Fee payer and signer. Sent 2 to this one and 1 to this one. That's what we expected. Use the system program. Transfer. Yeah. So there we go. So let's go in and look at these two. I think I looked at it. So let's do this. Okay, yeah, it looks like history goes away pretty quick on these, but yeah. Anyway, I mean, it works. They have that, so let's transfer some more just to validate. So we want to validate that we are pulling in the right one. So let's do that. I want to add another decimal here. Cargo run. Okay. Okay. Look at that. Transfer amount was that. Now can we see total balance? Okay. I'm gonna be honest. Let's do this again. Okay, so let's refresh and watch this, see if it jumps. 92, yep. 92. And there are two different 92s. 2 minutes ago was this. Writable. So there's that. Post balance. Okay, yep. And then post balance is 8s. And then 9s. Okay, yeah. So we are successfully pulling the key pairs that we created for those accounts. And we're sending and transferring SOL to them. I think we're good. I think this was a good video. I think we learned we learned how to deal with key pairs. We learned how to deal with multiple accounts. We learned how to create an account and then reference those later doing something. I feel like this was a good lesson. And we'll see what we're going to do next week. Thank you for your time, and I'll see you later.